Merry Christmas and welcome to Chapter 5. I know it's not really Christmas, but apparently I have taught this section before when it has been Christmas time. So we are a little ahead of the game. That's a little bit exciting. This is 5.1 Inequalities and Compound Sentences. Okay, objective and what's the point? This is all going to be a review mostly. We're going to graph some inequalities on a number line, and we're going to bring in the words and some symbols, unions, and intersections that you've seen before in geometry. Again, this is all review, but it's nice to have a little refresher. Is very important in the business professions. In fact, something we'll talk about later in this chapter is called linear programming, and I think that's probably one of the most essential tools that they do use in business when determining how much to produce of an object or price and stuff like that. Words to know: compound sentence when two clauses. Get it? It's in red because Santa wears a red suit. Okay, and they're connected by and or. That sounds like a seal, or. But those are the two words that are in compound sentences, and or. And first, let's talk about and for a second. This is intersection. Do you remember this from geometry? The symbol looked like this. And it was harder to get in that because I always said it looked like a closed cup when I taught geometry. It has to be true for both situations to be considered part of the intersection. When you graph it, it's going to look like one of two things, three things actually. It's going to be a segment that looks like this with two closed circles, an open circle and a closed circle, or a closed circle. Oh, four. Just kidding. Pretend I didn't say two and then three. Or completely open circles. Okay? You can write this with a double inequality. So let's talk about an example. Maybe we have 2 less than equal to x less than just less than 4. Okay, so you draw your number line. I hope you remember doing this. I think I did this in 6th grade if I remember. I bet you guys did too. We put a 2 here, 4 there. If you remember these signs, this is the less than or equal to. These are the less than signs. They straighten up to make a L. Okay. If it's equal, it's going to be a solid circle because that is including the 2. And 4 is going to be an open circle because not including the 4. That's very similar to an asymptote, which we saw in Chapter 2, that boundary line, because I can get super duper close to 4, but I'll never quite touch it. We are talking about, this is the segment in between here. We're talking about numbers that are bigger than 2 and less than 4. So that happens in this region. So all of these values on that segment will make this true. This is the double inequality, and this is the graph. Okay? This is the greater than sign, and that's the greater than equal to sign. These are the signs we're going to be dealing with today. Okay, this is a note because this will come up in your homework. If you read in a word problem the word between, that does not include the endpoints. We're talking about an open circle type example there. Otherwise, it will say from, and if it says from, that is including the endpoints, like from 2 to 4. Otherwise, it will say between if it doesn't want you to include the endpoints. Okay, moving right along, here's an example. Let's graph this one. X is bigger than 4 and x is less than or equal to 8. I want you to be careful because I remember thinking of this as a arrow. My teacher told me that I could put 4 on the graph, and then I could, this will be open circle, and this one's x is less than or equal to 8. This will be a solid circle. I could follow the direction of the arrow. Oh, look, I need to shade to the right because the arrow's pointing to the right. Oh, shade to the left because the arrow's pointing to the left. Okay, that only works if x is on the left-hand side. So I do want you to be careful when you're using that as a general rule because here, look, the arrow's pointing to the left, and I didn't shade to the left. You have to rearrange things first so that x is on the left-hand side. I think it would be easier for you to say 4 is less than x. So that means x has to be bigger than what 4 is, so that'll be to the right. Think about what the signs mean more than what they look like. That's going to be my advice to you. But here's what the graph will look like. Or, okay? Or is a union. It's a capital U in the symbol in geometry. Unions are easier to get into. If you think about a labor union, they want to have a lot of members so that they have more power. So only one situation needs to be true to be in a union. When you graph, it's going to look something like this. I say oars, if you will. Like I think of oars of a boat. Like here's my boat. There are the paddles or the oars. Okay, so I remember that the word oars graph is going to look like oars of the boat or the 2 rays. That's how I remember that. I don't care how you remember it, but you need to remember it, so might as well use my way. Um, you have to write these out separately. This is not an example of a or statement. This is an intersection. This is an and statement. This is the or statement right here. That is the union. In this example, what they're doing is they're saying these are the values that will work for a certain battery. So we are talking about where it won't work, and that has to be an or statement. They don't have the equal sign here because these values make it work, so they're not, if the battery is going to be rejected, it'll have to be less than 2.94, because if it was 2.94, it would have worked. And this is how you write it. You have to write it separately because it won't be true otherwise. If I have 2.9, oh, it doesn't want to write. If I have 2.94 and 3.06, and L in between here, and L is bigger, and it'll look like this. L can't be smaller than 2.94 at the same time that it's bigger than 3.06, so that's why you can't write them combined like that. Okay, so you do have to do it separately. Here's an example. Again, draw your number line. Put 12 and 65 on your number line. These are both going to be open circles because there's no equal sign. Okay, A is less than 12. Where is A less than 12? That would be in this direction. A is bigger than 65. Where does that happen? That happens over here. There's going to be some background noise, guys, because the bell rang, so just have to hang with me for 1 second. Okay, when you solve linear equations, let's have an example. Negative 2x plus 4 bigger than 12. You solve it just like this was an equal sign. There's one major exception. If you multiply or divide by -1, you're going to have to flip the inequality sign. Okay, I used to always tell my students, if you divide by negative and there's an unequal sign, that a red light goes off at the Pentagon, and if you don't flip the sign, they will send helicopters in and arrest you. So right here, when I divide by -2, I need to flip the sign. I have now x is less than -4. What this is telling me is if I plug in any number smaller than -4, that when I plug it in, it'll be true. So let's say -10. If I plug in -10, that's positive 20 plus 4. 24 is definitely bigger than 12. That whole region of values makes this statement true. Okay, so what you'll do tonight, you might have to solve and then graph, because if I graph this, I'll put -4 on here, open circle, shade to the left. Okay? I have a holly jolly homework assignment, and I'll give that to you tomorrow. Thanks a lot.